So if you're struggling with elimination, you're fine if it's set up perfectly for you, but if there's nothing that looks like it eliminates, this video might help. So let me give you an example. 9x minus 3y equals negative 3, and negative 18x plus 7y equals 10. So when you look at these, that doesn't look like a 10. There we go. When you look at these, it looks like nothing eliminates. If it's going to eliminate, it's going to be opposites. So like 9x and minus 18x are not opposites. They don't add to 0, so they don't eliminate. Minus 3y and plus 7y are not opposites, so they don't eliminate. But what you can do is you can focus on the x's and y's and think, well, what could I multiply by that would be nice, that would make it eliminate? So like if you look at the 9x and the minus 18x. 9 times 2 makes 18. So if I could multiply this by 2, it would work. Okay, so if you look at the y's, and you're thinking 3 and 7, you can't really add. It has to be a multiplication. So I wouldn't be able to multiply anything times 3 that would make 7, or nothing times 7 that would make 3. So I would be multiplying both of them by something to get them to look the same. So I'm going to choose the x's. And remember, you can choose the x's or the y's. In this example, the x's look like they'll eliminate nicely. So what you do is you decide what you want to multiply by that's going to make it nice for you to eliminate. So we already decided that was 2. When you do that, you have to multiply everything by 2. So I think that if you're looking at my labs, maybe it's not being clear about that. When you have an equation, if you want to make another equation that's equivalent, you can do that, but you have to do the same thing to all the terms inside the equation. If you don't do that, then it's not equal anymore. Okay, so 2 times 9x, I'm going to write my new equation over here, is 18x, and 2 times 3y is 6y, and 2 times negative 3 is negative 6. Then I'll rewrite the other one right below it. Now, this equation and this equation are equivalent. All I did was double everything, and that's okay as long as I do it to everything. So I'm no longer going to look over here. I'm going to look at my new equations, and they're set up nicely, and you can see that 18x minus 18x is going to eliminate to 0x, which is the elimination. Negative 6y plus 7y, I'm going to simplify that, and that's going to make 1y. And I'm going to simplify it on this side, minus 6 plus 10, or you can think of that as negative 6 plus 10. Either way, you're going to have 4 left over. And 1y is the same as y, so I get y equals 4. So my y is equal to 4. To find my x, I want to plug back into one of the original equations. So it doesn't matter which one you choose. I'm going to choose that top one. So the top equation was this. The reason it doesn't matter which one you choose is, think about what a solution to a systems is. It's the point where the lines cross. They share a point. If they both share 4, 4 should work in either equation. Okay, so I'm going to take the y, and I'm going to erase it, and I'm going to put this 4 in here and solve for x. So I get 9x minus 12 equals negative 3. Add 12 to both sides. I get 9x equals 9, and x equals 1. So I think that the point that they cross, if I was to graph them, is 1 and 4. If that's true, 1 and 4 is the only point that makes both of them true. So let's say I'm on a paper and it's late at night and I don't know if I'm doing it right, and I don't want to do 10 of them to find out that I did it all wrong and then try and get that out of my head. So let me show you on the next screen how to double check. It's not like you want to do this every single time, but you need to know that it's possible. Okay, so my solution was 1 and 4. I'm going to rewrite my equations again. My equation was 9x minus 3y equals negative 3, and the other equation was negative 18x plus 7y equals 10. So those were my two equations. So if this is true, and this 1, 4 is the solution, then it should work. It should make it true for both equations. So I'm going to take the x's and y's, and I'm going to replace it with the 1 and 4. So 9 times 1 minus 3 times 4. And that's 9 minus 12. And I'm going to see if that equals negative 3, like it says it's supposed to. And it does. So I know that that point works for that equation. But I want to make sure it works for the other one. So I'm going to take this equation, and I'm going to do the same thing. And I can see that it does. So that means that for sure, I know I'm right. I don't need an answer key. If that point works for both equations, then it's a guarantee it's right. Let's say that I screwed up, and I got a 5 right here. Okay? And I'm going through this thing, and I'm going, okay, well, I'm not sure if I'm right, so I'm going to check. And I go and I put 9 times 1 minus 3 times 5, and I get down here and I go, oh, wait a minute. Whoops, that's supposed to be a 3. And I go, I got negative 6 on the left, and I got negative 3 on the right. Those aren't equal. Then I know I screwed up, and I can go back and try and look for my error. The point has to work for both of them. If it doesn't, then it's not a solution. Think about visually. If I graph these two lines, and I don't know where they'd be on a graph off the top of my head, but if I graphed them, the point 1, 5 is the point that they would cross. Okay? So I'll give you one, and you can try it. You can pause it at any time and try it and then play. Let's see. Negative 6x plus 6y equals 24. And x minus 3y equals negative 24. So take a look at the x's and y's and decide which one is going to be the easiest to focus on to eliminate, and then decide what you're going to multiply to get that done. So you can pause it if you want. Okay, so I'm going to look at the x's, and it'd be really nice if this was 6. Okay, so I can multiply by 6. I can also look at the y's and say, well, it'd be really nice if this was 6, and 2 times 3 makes 6, so I can multiply everything by 2. So I got a choice. I can either multiply everything by 6 and focus on my x's, or I can multiply everything by 2 and focus on my y's. You just got to make a choice. You can't do both, because you can't multiply by 2 and then also multiply by 6. Okay, so I'm going to choose, let's see, last time we eliminated the x's. So I'm going to choose the y's this time. So let me change colors here. So if I choose the y's, that means I want this y to be a 6. So I'm going to multiply everything by 2 and write my new equation out here. So that would be 2x. That would be minus 6y. And that would be negative 48. And I've got that other equation. And it doesn't have to always be the bottom equation that you change. It can be either equation. Whatever works. It just depends on the numbers. So now, if I look at my y's, that's nice, because now I've got 6y minus 6y. So now I can start my elimination. Eliminate negative 6x plus 2x. I'm going to simplify that to negative 4x. And then 24 take away 48. I'm going to simplify that to a negative 24. I'm going to divide by negative 4, and I'm going to get x equals 6. And then I need the y, so I got to plug back in. I'm lazy. I'm going to plug back into the red one because it looks like it's going to be less work. So 6 minus 3y equals negative 24. Take away 6. Negative 3y equals negative 30. Divide by negative 3. And I get y equals 10. So I know my ordered pair is 6 and 10. That's the point that they cross. I could have chose the other equation, Let me do this real quick just to make sure that you know. I could have chose this equation, and it would have looked like this. Negative 6 times 6 plus 6y equals 24. That's going to give me a negative 36 plus 6y equals 24. I'm going to take 36 and move it over. This is getting sloppy, sorry. Oops. And I get 6y equals 60. Divide by 6, and I still get y equals 10. So it doesn't matter. Sometimes you have to multiply both equations, and those get a lot harder. Let me show you one of those. I can guarantee you there'll be either a substitution or elimination on the test, and there might even be both. But for sure there'll be one. And they tell you, you have to do it this way, and if you don't do it that way, you don't get any credit. Let me look at this one. Let's say this was your equation. Oh, I can't even read my own writing. 16, I think. Yeah. And negative 6x minus 5y equals negative 2. So when you're looking at these, I can look at the x's and I can say, okay, 6 and 8, they don't even match. I can't multiply 6 by something to get an 8, by a whole number anyway. I can't multiply an 8 by something to get a 6. So I go to my y's. Nope, can't do that either. 5 times nothing makes 9 if I'm looking at whole numbers, and vice versa. So when that happens, you just pick one. Pick the x's or the y's. I'm going to pick the y's. And you go, okay, well, I'm going to change color. I'm going to multiply this top one by 5 and this bottom one by 9, which is opposite of what they are. So that way they both make 45. Okay, so 5 times negative 8 is negative 40x. And 5 times 9 is 45y. And 5 times 16 is 80. And then I'm going to do the same thing with the other equation. So 9 times 6, let me change colors, different equation. 9 times 6, or negative 6, is negative 54. X minus 45y equals negative 18. So now, when I look at my y's, I'm closer to eliminating. But they're not quite, I can't really eliminate them because a negative 45 and a negative 45 make negative 90. They don't cross out. So what I can do is I can multiply everything on one of the equations by negative 1. When you multiply by negative 1, it just flips all the signs. So I'm going to do it to, I'll just do it to the top one. But you could do it to the bottom one too. So if I multiply 40x by negative 1, it makes positive 40. If I multiply 45y by negative 1, negative 45y by negative 1, it makes positive 45y. If I multiply 80 by negative 1, it makes negative 80. I did it all the way through the whole equation, just like I did with the 5 and the 9, so that's okay. All I did was multiply everything by negative 1. And I could have saved time by multiplying by negative 5 at the beginning. But I didn't know if you'd see that, so I thought I better show it afterwards. Okay, I tend to just do it afterwards, personally. So now I can take this, and these nicely eliminate. Let's see, 40 to 50, that's 14, so I get negative 14x on that side. And I get negative 98 on that side. And I get x equals 7. And then I can go plug my 7 in and continue. Okay, so those are probably the hardest where you have to multiply both of them. So hopefully this helps if you're on the elimination and you can eliminate them when they're set up nicely, but when they're not, you're like, I don't know what to do.